The primary goal of this presentation is to demonstrate that impact of memory tearing on guest performance is minimal when using Peaberry Accelerator. For this demo, we are using Oracle as the guest application. And our key performance metric is Oracle throughput, which is measured by the number of transactions committed by Oracle per minute. Now, let's walk through all the windows displayed on the screen, starting with the window on the bottom left corner, which shows vCenter console. Here in the left pane, vCenter shows that our testbed consists of two ESX hosts. The first ESX host is a Dell server configured with Intel Emerald Rapids processors. This Dell EMR host is equipped with Peaberry Accelerator and is running two VMs, the baseline VM and the memtier VM. Both VMs are configured with 12 vCPUs and 48 gigabytes of memory and are running Oracle as a guest application. The only difference between them is baseline VM does not have any memory tearing enabled, while the memtier VM has memory tearing enabled. The second ESX host is running two client VMs, Oracle Client 1 and Oracle Client 2. The Client 1 VM is generating load on the baseline VM, while Client 2 VM is generating an identical load on the memtier VM. We chose to run these client VMs on a separate ESX host to ensure they operate outside the system under test. The main objective of this demo is to show that even with 50% of the memory demoted to a higher latency device, the performance of the memtier VM remains identical to that of baseline VM. Now, let's shift our focus to the window on the top left corner. Here, we are presenting the console of the HammerDB client running inside the Client 1 VM, which is responsible for generating load on the Oracle instance running inside the baseline VM. The graph depicts time on x-axis and throughput on y-axis. And TPM here stands for transactions per minute. We observe Oracle throughput is reaching approximately 1.2 million transactions per minute. Also notice that HammerDB console updates the screen every 5 seconds. This is the baseline performance, and this figure here represents the highest achievable throughput since this baseline VM is not subject to any memory tearing. Now let's shift our focus to the top middle window. The window here displays the console of the HammerDB client running inside the Client 2 VM, which is responsible for generating load on the Oracle instance running in the memtier VM. Here we notice a slight decrease in Oracle throughput compared to the baseline performance. This is expected since this VM has memory tearing enabled, with 50% of its memory already demoted to a higher latency tier 1 device. Now let's shift our focus to the top right window, which shows the Oracle throughput in the memtier VM as a percentage of the baseline throughput. This metric is calculated by dividing the throughput of the Oracle instance running in the memtier VM by the baseline Oracle throughput and then multiplied by 100 to express it as a percentage. On average, we notice that Oracle throughput is approximately 88 to 93% of the baseline throughput. During this demo, pay close attention to this metric, as it is the most critical piece of information displayed on the screen. Our goal is to make memory tearing as transparent as possible to the guest. Therefore, the higher this number, the better the performance is. Now, let's shift our focus to the bottom right window that shows the breakdown of VM memory across different tiers. We see that nearly 24 gigabytes, that amounts to 50% of the VM memory, is currently demoted to the Peaberry device, shown as cxl.mem or the tier 1. The rest of the 24 gigabytes of the VM memory is still residing on the tier 0 DRAM. In addition, in this window, we also observe a continuous read and write access to the NVMe storage that's backing the Peaberry device. These continuous NVMe access are a direct result of the OLTP workload that we're using in this demo. This workload is based on TPCC profile that exhibits highly dynamic access pattern resulting in continuous changes to the guest working set. The NVMe axes that you're seeing in this window correspond precisely to these shifts in the guest memory access pattern. Specifically, the NVMe reads here correspond to the guest access to the pages that were previously identified as cold pages and were demoted to the NVMe storage. Similarly, all the NVMe writes that you see here correspond to the previously identified hot pages that are transitioning to a completely cold state and hence are being demoted to the NVMe storage. Also note that NVMe traffic here stays well within the SSD endurance limits. So even with a continuous 24/7 memory tiering operation, at this traffic level, the NVMe is expected to last well over half a decade. Now let's shift our focus back to the vCenter console, but focus on the right pane. Here, the graph here illustrates the memory usage of the memtier VM. The green line here shows that VM is utilizing all the 48 gigabytes of its configured memory. And in our demo, we already demonstrated that Peaberry device effectively can clear 50% of this memory. Additionally, the purple line here shows that approximately 70% of the memory is actively being used by the guest, which again means Peaberry device successfully cleared 20% of the VM's most active memory. At the start of this presentation, we outlined our goal of achieving 50% of the memory tier target with minimal performance impact. In our demo, we're able to demonstrate that even with the demanding workloads like Oracle and HAMDP, which have highly dynamic memory access patterns, the Peaberry device can help you reach that 50% target with only a moderate impact on guest performance.